All right, y'all, and I'm going to remind y'all about this little in behavior chart we made a while back. Remember, it looks at the degree of the polynomial, if the degree is even or whether the degree is odd. And it compares that with the lead coefficient. So the lead coefficient can be positive or negative. So I'm going to use this chart to determine the behavior of these problems we're doing. So like I said, this is test 3 review. All right, so number 1 wants me to use the in behavior diagram. I want to use the in behavior diagram to describe the in behavior. Of the given function. And y'all, like I said, we'll use this for the first 2 problems for sure. So this one has P of X equals negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 4. So the first thing I'm going to look at is my degree. Is my degree even or odd? And remember, the degree is the highest exponent of the polynomial. So for this one, my degree is 6, which is even. So my degree is even. Then I look at the lead coefficient, whether it's positive or negative. Well, y'all, my lead coefficient is that negative pi, which is negative. So my lead coefficient is negative. So now I'm just going to go to my chart. I got an even degree. My lead coefficient's negative. So I'm looking at the end behavior where both ends head down. So we just want to choose the picture that has both ends going down. And remember, they'll give you the 4 pictures. You just got to choose one that matches your graph.
Can you tell me how you got that again? I'm sorry.
So remember, this compares your degree, which could be even exponents or odd exponents. And then we look at the lead coefficient, which is the number in front of the variable that had the highest exponent. So since my highest exponent was 6, that gave me the even degree. So when it's even, you either got a positive first coefficient or a negative lead coefficient. So then I look at the number in front of my x to the 6, which was the negative pi. So that pi was negative. So negative brought me down to the picture where they was both heading down. If that would have been a positive pi, then I went to the one above it where they both went uphill.
Thank you.
Oh, you also look at this one. This one has a f of x equals negative 4.3 x to the 4th plus x to the 6th plus a 0.2 x to the 7th. So the first thing we got to do is find the degree. So I'm looking for the highest exponent.
0.
That's what is 0.
X to the 6th. Oh, 0.2.
X to the 7th there. So that 7 is odd. So my degree is odd this time. So now we got to determine whether that 0.2 is positive or negative. So that means my lead coefficient. Now this one's out of order is what they're trying to do to this one. But that 0.2 is positive. So that means my lead coefficient is positive. So when your degree is odd, you got these two choices. Positive lead coefficient goes uphill. A negative lead coefficient goes downhill. So since we're odd and positive, ours is going to go uphill from left to right. And choose the picture that has it doing that. All right, so remember the first two, have this in hand because that's what you're going by on those first two, okay? Now, for number 3, they start getting into the zeros. So number 3 wants us to find the zeros of the polynomial. And the multiplicity of each. All right, so let's see. The polynomial they're giving us is f of x equals x squared minus 16 inside the parentheses, and then exponent 3 on the outside. So the zeros are going to come from the factors that are inside the parentheses. This 3 right here, this 3 is the multiplicity, because remember, that 3 is telling me that I would write that x squared minus 16 3 times. So the 3 is my multiplicity. So what we got to do is find what zeros we're going to get. So we're going to take that x squared minus 16. And since we're finding zeros, we're going to set it equal to 0. And y'all remember that x squared, since that's an exponent 2 on that, we got to have 2 zeros when we're done with this. All right, y'all. So the easiest way to solve this one would be to add 16 and do the square root to this. So we're going to come in, add 16. So I get an x squared equals 16. And then I'm going to take square roots of both sides. So square root of x squared to give me an x. Now remember, square root of 16, we need to use our plus or minus on that. And then take square root of 16, which will give us 4. So my zeros are plus or minus 4. And each has a multiplicity of 3. Okay, so remember that the outside exponent gives you your multiplicity. The factor inside the parentheses gives us those actual zeros, okay? All right, so I'm gonna let y'all catch up and then I'll do 4 on the other side. Looks like I'm having people get knocked off and back on here. Let's see, yeah. Okay, also let's go to number 4 now. And y'all, number 4 is the same thing, finding zeros and multiplicity. All right, so now they're giving me already one that's been broke down. I'm going to have f of x equals negative 2 times x minus 5 to the 4th, x plus 3 squared, and then at the end is a x to the 3rd. Now, since I'm looking for zeros, I'm only going to get zeros from the factors that have a variable. So I'm looking at the x minus 5, the x plus 3, and the x. Since this -2 does not have a variable with it, you can cross that one out of the way. It's just what we call a constant term, and it does not give me a zero from that factor. But y'all, the other three factors do have the variable. So I'm going to set each of them equal to 0. And then I'll set my x plus 3 equal to 0. And then I'll bring down that x and set it equal to 0. And remember, the single x is always equal to 0 when you played with those. So what we're going to do is solve these two to get the actual solutions. So add 5. And again, x equals a 5. Subtract 3. And again, x equals a -3. Okay, so I got the zeros now. I got 3 zeros. So let's see how they got the answers. The first one says the 0, 5 has multiplicity blank. So what goes in that line?
4.
So there you go, because that 0, 5 came from this factor, which has a exponent of 4 sitting there. All right, then it says blank is a 0 of multiplicity 2.
-3.
So -3, good job, because -3 came from the factor where the 2 was. Then it says the remaining 0 is blank. It has multiplicity blank. All right, also what y'all putting in there? The remaining 0 is?
1.
Well, remember, y'all got the 5 already here. We took care of that one. We got the -3 here.
0 and
No, so the last 0
3.
is the 0. And it had a multiplicity of
3.
3. There you go. Okay, so you solve the factors for the zeros, and then you're just looking at those exponents up there for those multiplicities, okay? All right, so number 5 is probably one of the trickier ones. It wants me to find the zeros again and state the multiplicities. But y'all, this one we're going to have to factor because they're giving me a polynomial that has not been factored. They're giving me a x to the 3rd minus a 6x squared minus a x plus 6. So this was the 4-term polynomial, and what we did to factor that, we set this up into 2 groups. The first 2 terms and then the last 2 terms. And on each group, we factored out the GCF. So we're going to factor out the GCF of each group. So y'all, the first one has an x to the 3rd, a -6x squared. What would y'all factor out as that GCF?
X squared.
X squared, good job. And y'all, that's factoring out an x squared. That's going to leave me an x minus the 6. Now remember, when I factor out the second GCF, it has the same sign as the 3rd term here. So since this 3rd term is -x, our next GCF will be negative. And y'all, guess what? What can I factor out of an X and a 6?
One.
A1, there you go. So if you factor out a -1 on this, the negative divided by negative makes that a positive X. The 6 divided by the negative makes that a -6. Because remember, at this point, these parentheses got to match up like we got. So then I made 2 more sets of parentheses. Do y'all remember what I put in these parentheses?
X squared minus 1 and x minus 6.
There you go. The parentheses matched up. They make one parenthesis. Everything on the outside made the other one. Good job. So now I've got it factored. And remember, at this point, since I don't have exponents by these parentheses down here, you would treat them both like they got a 1 by them. So that's going to be their multiplicities, is those 1s. So now to find the actual zeros, I'm going to take the x squared minus 1, set it equal to 0, and then the x minus 6, set it equal to 0. Now remember, since this was the x to the 3rd up here, that exponent 3 tells me we got to get 3 zeros when we're done. And y'all, looks like 2 of them are going to be over here, and then the other one here. So y'all, the easiest thing to do to this is to add 1 and do a square root to it. So the square root of x squared will equal the square root of 1. And remember, since I'm doing a square root, I'm going to do the plus or minus. And then I guess what? Square root of 1 is 1. So I got 1 is a 0, -1 is a 0. And over here, we're going to add 6 to solve this equation. And we get x equals 6. So it would have an answer blank like the zeros are blank. Each 0 has multiplicity blank. All right, so our zeros are going to be these 3 answers we got. We got a 1, -1, and a positive 6. And then we said each of these had a multiplicity of
1.
1. There you go. Oh, then I got a little true or false here. Now, this is dealing with whether the graph crosses the x-axis at a 0 or whether it's tangent. So let me bring back some memories. If the degree is even, then it was tangent to the x-axis. That means it came down, sort of touched it, and curved back up. If the degree is odd, then that means it crosses over at that 0. Okay, so for this problem, you got to figure out which factor they got the 0 from, and then look at that degree to see if it's even or odd, okay? So now here's the question. If P of X equals x minus 2 to the 8th, x plus 7 to the 3rd, then the graph crosses the x-axis at the point 2, 0. So I want to know if that is true or false. At the 0 of 2, or the x-axis at 2, 0, is this graph going to cross over or is it going to be tangent? So y'all, here we go. To get that answer 2, 0, it had to come from this factor, right? X minus 2 to the 8. So then, since that's a factor where they got that, I look at this 8 here. The 8 is even. And we said right here, if the degree is even, it would be tangent to the x-axis. But right here, they said it crosses. So that's going to make this false. And you sort of got to put a reason by. Okay, so let's see. We put false. And you want to look for the one that says it's false because the exponent is even. Thus the graph is tangent at 2, 0. Okay. Now, had that been a 5, 7 or something like that, which is odd, then that would have been true. It would have crossed over that x-axis, okay? So on that one, they're going to give you that x-intercept, find which of your factors it came from, and look at that exponent. And these are your two choices, okay? Even, tangent, odd, crosses. All right, so let me let y'all catch up a second, then I'll flip her over. All right, y'all, so moving on, number 7. So for this one, they want me to find the maximum real zeros. The maximum x-intercepts. And the maximum number of turning points. All right, so they're giving us f of x equals negative 7x minus x to the 5th. All right, so over here, we'll put our blanks. Maximum real zeros. Maximum x-intercepts. And then max turning points. So y'all, for this one, I looked at the degree. The degree of this is a 5. So since the degree is a 5, what would y'all put in these 3 blanks? What is the maximum number of real zeros?
5.
All righty. How about the maximum number of x-intercepts?
2.
Now y'all remember this. X-intercepts and zeros are the same things. So if these real zeros is 5, then those max intercepts, they better be 5 also. So the one that's different is the max turning points. So if I got a degree 5, what is the maximum number of turning points I can have? It's been a while since y'all done this. But remember, max zeros equals the degree, max intercepts equals the degree, max turning points equals the degree minus 1.
4.
So that's going to put me at 4. There you go. Okay, so remember, same, minus 1, okay? All right, now these next two I'm going to do on the graph because they just want me to sketch the graph. But they're going to give you 4 pictures, and you're just going to choose one of the pictures. So let's see, I got h of x equals x times the x minus 4 times the x plus 4 times x minus 6. Now, I will say this, on the graphs they're using, they go from -10 to 10 on the x-axis, but y'all, the y-axis goes from -100 to 100. So I want to show you how to set that window on that calculator so that you can get the exact picture of what they got. So we're going to go to the calculator and put this in.
Is there a calculator app I can get? I lost my calculators in the tornado. So
Yeah, so what I would do if you lost a calculator or something, go to your, what's it called, the Apple Store or the Google Store for the Androids, and search a TI-84 calculator app, and they'll have them on there all day long.
okay, thank you.
And now they'll do everything we're doing here, okay? All right, y'all. So first we want y equals. And I'm gonna put in what I had. I had an x. Then I had parentheses. I had what? X minus 4. Close parentheses. Then I had a x plus 4. And then finally I had an x minus 6. Now to set that window, what I need, I'm going to push the window button that's right next to the y equals. Push that window. Now my x's are good. They're from -10 to 10. But arrow down to where it says y minimum. And y minimum, I want to be a -100. And then I'm going to arrow down to the y max and make that a +100. All right, so let me see what my chat's saying. Okay, so Tamika was just telling y'all that there's one in the App Store called Calc 84. Okay. All right,
I got it. I forgot I had it on my iPad, but I have it. Thank you.
okay. All right. Thank you, Tamika. All right, y'all. So I got everything in on the window like the graph says. So I'm just going to hit graph. And there you go. So I'm going to show y'all the picture here. Let me show you. So mine looks like a W, sort of. So if you look like on their 4 pictures, here's the one that sort of looked like that W that we had on our graph, okay? So that's the easiest thing to do on that, is just throw it on our calculator and let it do that work for us. So y'all, let me see 9. Same thing, they want me to graph again. This time they're giving us f of x equals 15x to the 3rd minus 6x squared minus 60x plus 24. Now, y'all, really, I'm going to show you on this one. Remember, that's the x to the 3rd, and it's a positive lead coefficient. So we've seen from the end behavior chart Y'all hang on, I'm trying to find my cursor here. Ooh, my mouse is froze. Hang on a second. Right, there it goes. All right, so what I was saying, we seen on the end behavior chart when it was an odd degree and a positive lead coefficient, that thing was sort of going to go uphill left to right. So let me show you these graphs. They're looking at these graphs right here. This one looks like both ends go up. So this one does go uphill left to right. This third one goes uphill left to right, and then the last one goes downhill. So knowing what we know about our lead coefficients and the end behavior, it's going to be B or C. So y'all see this 24 at the end? That's the y-intercept. Anytime a number at the end, that's your y-intercept. So that means, let me make this a little larger. That means one of these graphs is going to be crossing at 24. Now it's hard to tell, but here's the 0 on this one. That one's a little bit above. This number C, it's going right through the center. So between those two, the only one that can have a y-intercept at 24 would be the B on that one. Okay, and you remember this is going from negative 250 to 250. So I'm going to graph it now to show you that it should look like that B there. Oh, my cursor keeps freezing on me. I think it's my. All right, I got it back. All right, so let me go to the graph calculator. All right, so I'm going to go to y equals, clear that one out. So this was 15x to the third. Minus 6x squared. O minus 60x. And then plus 24. Now on the window, this one went from -5 to 5 on the x's. So I'm going to go -5, arrow down and make that one a 5. My y values went from -250 to positive 250. Oh, that's a big y value. And they're making them so big so that we can see the whole graph on these. So y'all, let's hit graph. And notice you can tell it's close to that center, but it's just a little bit up. And remember, that thing's going by, ooh, that thing's probably going by 25 a notch. Okay. So it is the one where it's just a little bit above that origin on it, okay? I tell you, they make some of these so close, it's hard, but you just got to play with them and look at them, okay? All right, y'all. Then we get into the fun stuff like the let's see my thing. We're going to get into the fun stuff using synthetic division. So using synthetic division, I'm going to determine whether the numbers are zeros. Of the function. All right, so my function would have given me -3, 1, and then a semicolon h of x equals x to the 4th plus 4x to the 3rd plus 3x squared minus 7x minus 1. So I will pull this down now. So remember, I got to do this twice. The first number I'm going to check is -3, and then the second number I'll check is the 1. Now, I'm going to get my coefficients from this polynomial. So my coefficients are the numbers. So I got a 1 for the x to the 4th, a 4 for the x to the 3rd, a 3 for the x squared, a -7 for the x, and then a -1 for the constant term there. I'm going to draw my box. Now my first C that I'm going to check is going to be the -3. So y'all, here's a question for this one. If this -3 is in fact a 0, for me to tell it yes, what does that remainder have to be?
0.
It's got to be 0. There you go. All right, y'all. So let's see. Remember the 1. We're going to bring the 1 straight down. And then we're going to multiply, add until we're done. So 1 times -3 is -3. 4 and -3 going to give you a 1. 1 times -3 is -3. Well, y'all, 3 and -3 give me 0. 0 times -3 is -3. All right, -7, -3, give me -10. So y'all, this one's not looking too good. I got -10 times -3 is 30. So there's no way I'm getting a 0 in here. It looks like I'm getting what, a 29. So for 3, you're going to put a big no. Now then you'll come over here and check the 1. So it's the same coefficients, 1, 4, 3, -7, and -1. All right, y'all, so let's check this and bring that 1 down. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 3 and 5 give me 8. All right, so let me see. So I got a chat. Wouldn't -3 times 0 equals 0? So where are we seeing that at? You talking about this first one here, Stacy?
Yes, where you get the 0 times 3, and then you do negatives, -7, -3.
Yeah, y'all, let me finish this. Ooh, my bad. I didn't catch that. I get to talking and then I miss my stuff, y'all. So let's try this first one over. Then we'll finish that one. Yeah, right here, 0 times -3 should have been a 0 right here. Right? All right, so let me follow that through again. Bring the 1 down. 1 times -3 is -3. 4 plus -3 is 1. 1 times -3 is -3. 3 plus -3 is 0. Yeah, right here. Good thing you caught me. 0 times -3 is 0. -7 and 0 is -7. And then -7 times -3 would be 21. And then that gives me what, a remainder of 20. So, whoo, glad you caught that, but at least on that mess up, I still would have got to know, right? All righty, so. All right, y'all, here we go. So finishing this one up, 8 times 1 is 8. 8 and a negative 7 is 1. And then 1 times 1 is 1. And y'all look at that. Negative 1 and 1 give me a remainder of 0. So the second one for the 1 would be a yes. Well, hopefully if y'all mess up like I did, y'all still get a right answer on that, okay? All righty, y'all, let's flip over and we'll get into number 11. All right, so let me push this back up. All right, 11. Suppose a polynomial degree 4, so a polynomial degree 4 has the following zeros. Then it wants me to find the other zeros. Okay, so the zeros they're giving me is an I and then 3 minus square root of 5. So here we go. The other zeros are blank. So remember, polynomial 4 will have 4 zeros altogether. So they're giving you 2 of them. So y'all, what are the other 2 zeros?
Negative I and 3 plus square root of 5.
Perfect. Negative I and 3 plus square root of 5. Good job, y'all, because remember, these always come in what we called conjugate pairs, okay? Now, 12. You've been missing your foiling. So number 12, we're going to get to do a little foiling. We're going to find a polynomial of lowest degree that has the following as sum of its zeros. So this is the one where we got to do a lot of foiling. So let's see. The zeros they're giving me are a square root of 2 and 4i. So y'all, let me ask you this. They're giving me 2 of these zeros. Automatically, if they give me them 2 zeros, what else has to be zeros?
Negative square 2 and negative 4i.
Square 2, and then what'd you say, negative 4i? There you go, because remember, if they're giving you a radical, you know it's opposite. They're giving you imaginary, you know it's opposite. So y'all, this is the one where we're going to find a polynomial. So we're going to set our x's equal to these 4 zeros we got. And I'm going to put them together. I'm going to put my imaginary stuff together. So I'm going to put a 4i here and a negative 4i. Then I'll do a square root of 2 and a negative square root of 2. So remember, I need zeros on the right side. So add and subtract to get these moved to the left side. So the first one will subtract 4i. Second one, I'll add 4i. Then I'll subtract that square root of 2 from both sides. And then add the square root of 2 to both sides on the last one. So we have our 4 equations. So this is the point where I put them all in parentheses and set the whole thing equal to 0.
Can you slow down just a little bit?
Oh, I will. So then put them all in parentheses equal to 0 on that. And then we'll get to the fun part.
Okay, thank you.
Now, I'm going to FOIL the conjugate pairs together. And y'all, here's the thing. Since these are conjugate pairs, we can shortcut FOIL these. So I'm going to shortcut FOIL. Remember, I don't have to FOIL the whole thing out because the center's always canceled. So the shortcut FOIL in the first parentheses, I'm going to FOIL the x times x, which is an x squared. And then I'm going to FOIL the negative 4i times 4i is a negative 16i squared. And then I'm going to start on this one. It's conjugate pairs, y'all. So we're going to shortcut this one. X times x is an x squared. Then I got a negative times a positive again. That's going to give you a negative square root. Well, 2 times 2 under the radicals gives me a 4. So at the moment, I got x squared minus 16i squared times the x squared minus the square root of 4. So y'all, we're going to simplify them even further before I do my last step. Here's my question. You got a negative 16i squared here. What is that going to turn into?
A negative 1 to be a positive 16.
There you go. Y'all, you got to treat the I squared as a negative 1. So that's going to give me an x squared plus 16. And over here, well, y'all can take the square root of that 4, right? So the x squared minus the square root of 4, the square root of 4 will turn into a 2. All right, y'all, so you see what we got now. I got these 2 things here, these 2 things here. This one, these are not conjugate pairs. So these 2, we have to FOIL all the way out. Okay, we can only shortcut when you got the conjugate stuff going on. So here we go. We got the x squared times the x squared is going to give you an x to the 4th. Well, y'all, we need an exponent 4 here because we had 4 zeros, okay? Now, x squared times negative 2 is a negative 2x squared. 16 times x squared is a positive 16x squared. And then finally, 16 times negative 2 is a negative 32. All righty, can y'all go further on that?
Combine like terms.
Divide by 2.
And that's right in the middle, right? So y'all we get what, an x to the 4th. What we got, a 16 minus 2 would be a, what, a 14x squared minus our 32. And this is what MathLab wants, is just that polynomial. So y'all, on this one, please remember you got the opposites or the conjugates as zeros, and then FOIL those conjugate pairs before you do any of this, okay? If you don't start with them conjugates, you'll get some ugly looking equations going on. All right, y'all. So y'all ready for 13? All right. Y'all, 13 says the polynomial has the given zero, find the other zeros. So give me a given zero, and then I'm going to find the other zeros. All righty, so let's see what they're giving me. They're giving us f of x equals x to the third plus 2x squared minus 3x minus 6, and then the semicolon. So the zero they're giving me is a -2. So remember, since this is an x to the third, we're going to get 3 zeros, and they're giving us one of them. So we just got to find the last two. So what we got to do is take this -2 and do a little synthetic division. So I'm going to write down my numbers. I got a 1, 2, -3 for the x, and then my -6. Remember, once I get this down to 3 numbers for my quotient, I'm going to use either the quadratic formula, factor it, or square roots. But we got to get it down to 3 numbers before we can do the quadratic stuff to it, okay? Now, here's the thing. If they're telling me this is a 0, then when you get done with this synthetic division, we better have a 0 here, okay? All right, y'all, let's find them other 2 zeros. So the first thing we're going to do, bring our 1 down. 1 times -2.
Well, it's starting to go this way, and I heard him the bill, so.
Say again.
0.
He can't hear you.
Oh, I heard a question, but I didn't hear what it was.
I think it's somebody's background interrupting.
Oh, okay. Okay. All righty, y'all. So here we go. Bring that 1 down. 1 times -2 is -2. 2 and -2 gives me a 0. 0 times -2 is 0. -3 plus 0 is -3. And y'all, here we go. -3 times -2 is a +6, which gives me a 0 remainder. Now remember, these 3 numbers are the coefficients of the new polynomial that starts 1 degree less than this polynomial. So that means this is 1x squared plus 0 x's minus 3. And if I'm going to find them last 2 zeros, I'm going to set that equal to 0. All right, y'all. So remember, these 3 numbers, if you had the quad formula, just punch in a 1, 0, -3 for your ABC on the quad if you want. But y'all, this one, number 13, always ends up like this with a 0 in the middle. And the easiest way to solve this is just take a square root of both sides. So we're going to add 3. And I get x squared equals a +3. And then I'm going to do square roots to both sides. Oh, I remember, I forgot to unzoom a while ago. Okay. So now, square root of x squared equals the square root of 3. So y'all, that's going to give us an x. Remember, square root of 3 is going to be a plus or minus. And y'all, we can't do nothing with that square root of 3, so I'm going to leave that a square root of 3. Now, here's where people get in trouble. The answer blank only wants the other zeros. It does not want that -2. Now, if you accidentally put the -2 plus the 2 we got, I'll look at those and I'll give you credit on those. But remember, this only wants the other 2 zeros, which are going to be the positive square root of 3 and then a negative square root of 3. Okay? It don't want them all. It just wants the 2 that you find. Oh, and y'all, here's another fun one. Number 14. List all possible rational zeros. So they're giving you f of x equals 15x to the 6th plus 12x to the 3rd minus 7x squared minus 2x plus 7. So y'all, to get all these possible zeros, this is the one where I took all the factors of the last number. So my last number is a positive 7 and divided by all the factors of the first number. So my first number is a 15. So I'm going to find all the factors of 7, then all the factors of 15. And y'all, what's nice on this, 7 only has 2 factors. It has a 1 and a 7. Now the 15 is what? 1 times 15. Then I can do 3 times 5. So the factors of 15 are 1, 3, 5, and 15. So take both of these 2 numbers, the 1, divide by all 4 of these. Then we'll take the 7, divide by all 4 of those. Also remember, every one of them, we have to use the plus or minus. So let me start with the 1. I'm going to take that 1, divide by 1. I'm going to take that 1, divide by 3. I'm going to take that 1, divide by 5. And then finally, I'll take that 1, divide by 15. Now remember, if you can simplify any of these fractions, you got to. And the only one I can simplify is the 1 over 1. That'll just become a 1. So y'all, that took care of the 1 being divided. So now we come in and do that with the 7. So I'll have a plus or minus 7 divided by 1. Plus or minus 7 divided by the 3. Plus or minus 7 divided by the 5. And then plus or minus 7 divided by 15. And y'all, once again, this one right here, I can simplify and make that just a plus or minus 7. Oh, my computer. Hang on, y'all. I got to freeze up on it. All righty. What's happening, I guess, every time someone gets knocked off and back on, it's freezing my computer up, my mouse, from having to get it unfroze. Yeah, y'all. So just remember, it's the last number divided by the factors of the first number, okay? And they sort of try to trick you by going the other way. All right, y'all. So let me see. You ready to flip? So 15. 15 wants me to find the domain. And actually, there's two in a row doing domain. This one will have me do set builder notation and interval notation. 16 just has me do interval notation. So to find a domain of f of x equals x to the third minus x squared plus the x plus 1 all divided by x squared plus 7x plus 6. So to find the domain, we're going to take the bottom and set it equal to 0. And y'all, to solve this, I'm going to factor. So I'll have y'all help me factor this. I got an x and an x. So give me some signs for these two factors.
Positive and positive. My bad.
Okay, that's good. And then what factors of 6 do I need to get that 7?
6 and 1.
6 and 1. All right, so she got me factored. So now I'm going to set both of those equal to 0 so I can get my solutions. So subtract 6 on our first one. Subtract 1 on the second. So on this one, since you got two numbers we're going to exclude, they got one on here and it says use ascending order. What ascending order means is go from the smallest number to the largest number. So that would be the one that looks like this. X such that X is a real number. And X cannot equal blank. And X cannot equal blank. So remember, ascending order is the small to the large. So you would put your -6 first, and then your -1. And the reason they're doing that is for your interval notation. Interval notation, going to start all the way out here at -infinity. You're cruising along until you hit -6. So at -6, we're going to union around -6 until we hit -1. All right, once we hit -1, we're going to union around that -1 until we hit positive infinity. And y'all, that's the whole reason they did this order here, because they know people have trouble with the negative numbers. So they wanted you to put these in ascending order so that when you came down here, you had the interval in the right order, okay?
Can you give me just a second to write that?
Oh, yeah.
Last- Okay, give me just a second. Okay, you can go ahead.
All right, y'all, same thing, find the domain.
Can you give me just a second? Just a second.
And y'all, this domain will be only in interval notation, okay? So let's see what they're giving us. F of x equals, I got a -2 on top over x squared minus 2x minus 35. So the same thing I did here, I'm going to take the bottom only and set it equal to 0. And y'all, once again, we're going to factor it. So the x squared gives me an x and an x. Now, let me tell you, if you don't like factoring, the only other choice you got is using the quadratic formula to solve these. It's a lot more tedious, but it will work, okay? All righty, who's my factor person? What signs?
minus and a minus,
Oh, I got you on that.
minus and a plus, I think.
There you go, minus and a plus. Remember, the last one's negative. You got unlike signs. All right, so can you find me the factors of 35? That'll subtract to give me that 2.
75, maybe.
75.
There you go, -7 and +5. All right, so I'm just going to solve them now to get those two numbers that we need to kick out of our domain. So we'll add 7 and get a +7, subtract 5, and get a -5. So interval notation will start at -infinity. So let's see, we're going to hit what? -5 first. So we go around -5 in union. From -5, it goes until it hits that 7. So we're going to union around that 7 and nothing else comes out. So we head towards infinity. So y'all, in the long run, these two problems are basically the same. The only difference is this one had to, they made you do a little bit of set builder notation, okay? All right, y'all, 17, determine the vertical asymptote. And y'all, I ain't gonna lie. These vertical asymptotes is pretty much like finding the domain stuff. Except you got to check one thing on these. So let's see what I got. I got a g of x. It's going to be an x to the third on top over 2x to the third minus the x squared minus 10x. All righty, so vertical asymptotes, we take the bottom, set it equal to 0. Now, the first thing you would do to that, since everybody has an x in them, we're going to factor that one x out. Remember, always start with a GCF if you got one, okay? So if I factor the x out, that's going to give me a 2x squared minus the x minus my 10, all equal to 0. So now the trouble is going to be factoring this middle. Now, I'm not going to lie, you could set up parentheses and do trial and error on that, which means you'd put a 2 in 1 and an x and then play with the numbers until you got what you needed in this. To factor it, you could use a quadratic formula to factor it. Now I'm actually going to factor it doing, I think I showed y'all this one night. So let me see. This is one where I had a number up front. So what I did, I took that number and multiplied by the last number. So 2 times 10 gives me 20. And I'm not worried about the signs because I'll take care of the signs when I find my two numbers. So now we would treat 20 like it was the last number. So the first thing, y'all, can you give me factors of 20 that'll subtract to give me the 1 in the middle?
Five and 4.
So that's going to be a 5 and a 4. Now remember, at this point, the larger sign has the same sign as the middle number. So at this point, I know my 5's negative and my 4 would be positive. Now, I borrowed that 2, multiplied by the 10 to make the 20. I found factors of 20 that gave me that 1 in the middle. And if you notice, -5 and 4 equal -1 like we needed. Now, do y'all remember what I have to divide both these by? All right, so here's the thing. Since we borrowed this 2 and multiplied by the 10 to get to 20, once you got your two numbers, you got to divide both them by the 2. So you multiply by the 2 here, and then you divide the 2 back out at this point. Now, I can't do nothing with that negative 5/2, but y'all, this 4/2 will reduce to just a 2. Now, these are the factors, remember, I'm factoring it to get these two numbers. The actual x's, well, y'all, what have we learned about factors and solutions? Like right here, your factor was right here, your factor was x plus 6. My answer was a -6. You had a +1, your answer was -1. Same thing here. Factor was -7, you ended up with a 7. +5 gave me -5. So if this is a -5/2, it's going to give me a +5/2. And this one is a +2. That's going to give me a -2. So remember, change signs for the solutions. So this x, if you set it equal to 0, equals 0. Then you had x equals 5/2. And then x equaled -2. Now, y'all, if you did the quadratic formula to this, it would give you 5/2 and -2 out of it, okay? So, y'all, here's a question I would ask y'all. Can I keep all three of these vertical asymptotes? Because if you remember, I got to look at the top, don't I? And you got an x to the third sitting up there. Remember, that x to the third is really an x times the x times the x. So do y'all remember? You got x's up top. You had that x on the bottom. This x is going to cancel out that asymptote with one of those x's on top. If that cancels, that's going to cancel out x equals 0 as a vertical asymptote. So always got to check them to make sure none of the factors on top cancel with none of your factors on bottom. So then my answers is the vertical asymptotes let's see what they got. Is x equals blank. Well, I would put in my 5/2 and my -2. Y'all, I'm going to tell y'all a secret on this one. Y'all are going to have an x to the third on top, and you're going to have some kind of x to the third on the bottom, x squared and an x. You will have one of your asymptotes canceled out, just like I did. And it's going to be the one that gives you the 0, okay? It's going to be the same format. The only two answers you really need to find is what you're getting from this 2x squared minus the x minus 10. Y'all probably have a 3x squared or something different, okay? But you're only going to get 2 vertical asymptotes for number 17.
Yeah, I think the quadratic formula is a
Say
better
again.
use. I said I think the quadratic formula is a better use. I mean, I get you're showing the steps, but the quadratic formula.
Yeah. Yeah, and we've only had one problem doing this kind of factoring all year. So get on that quad and use it because it'll spit that out quick, okay? And really our foundations, if you had that class, they don't really do enough factoring in there. I wish they did more with the numbers in front, but they just ain't got time. All right, y'all, let's see what this is. 18. Not as bad. This one just wants me to determine the horizontal asymptote. So they're giving me f of x equals x squared minus 8 over 6x to the 4th plus 5. So y'all, you don't really have to do much work on this one. You just got to look at the degree of the top, which is a 2. That the degree of the bottom is a 4. So the bottom is greater than the top. So y'all, let me ask you this. When the bottom is greater than the top, what is your horizontal asymptote? And it's going to be a y equals what?
0.
0. Good job. And all you got to do, they'll have the y equals. All you got to do is put the 0. So remember, if it's bottom heavy, it's 0. If it was top heavy, there's no horizontal asymptote. And if they were equal, say both of these were 4, then I would look at the numbers in the front and it would be a 1/6. So compare the degrees and move on. And then there's the last thing we did, these last 2 problems. Solve the following inequality. Now this one's already factored. X minus 2 times x plus 1 has to be less than 0. So y'all, we're going to take both these factors, set them equal to 0. Solve those, because remember, this is the one where I set up the little number line. So the first number I get is a positive 2. Let's say the second one, we'll subtract 1 and get a -1. So remember, I set up a number line. Let's see, -1 would be here and 2 would be here. Because remember, I got to figure out where I'm going to shade this. Once I figure out where I shade it, then I'll set up my interval notation. And y'all, I'll tell you what, I always test 0. And 0 is in between -1 and 2 somewhere. If it's true, I'll shade it, and that'll be my interval. If it's false, I'm going to shade the outside edges, and those will make up my interval. So for me to test 0, I'm going to put a 0 in for these x's. So 0 minus 2, 0 plus 1 has to be less than 0. So y'all, let's see if that's true or false. I'm going to get a -2 here times a +1. So y'all, the question of the day is -2 less than 0, true or false?
True.
So that is definitely true. So what that means, since it was true where 0 was located, we would come in and shade in between the -1 and 2. So since I've only got one interval, my interval notation will only have the one interval. But y'all, here's my question. Would I use parentheses or brackets?
Parentheses.
I'm going to definitely use parentheses. Good job. And it's going to go from the -1 to the +2 and be done. Now remember, had that have an equal bar under it, then we would have used our brackets, okay? But we didn't have the equals, so it has to be the curves. All right, y'all, last one on this test. Same thing, solve the inequality. I got an x squared plus a 20 is less than 8x. All right, so y'all remember the thing on this one. I need everything on one side equal to 0. So the 8x is on the wrong side. So you need to subtract 8x from both sides. And I'm just putting it in the middle because I know that's where it's going to go when I bring this down. So I'm going to have my x squared minus the 8x plus the 20 is now less than 0. Now, y'all, let's factor this. Now, I'll actually set it equal to 0 when I factor it. But we know we got an x and an x. All right, what kind of signs would y'all put on this?
I believe negative and negative.
There you go. Last sign's positive, both are negative like the middle. All righty, so what we need to do now is find some factors of 20 that'll add and get an 8. So let me think. 20 can be 1 times 20. Those don't add to get me 8. What's next, y'all? 2 and 10. 2 and 10 don't add to get 8. Although they subtract, they don't add. I need them to add, remember. What's next? 3 don't work. How about 4 and 5? Well, 4 and 5 add to get a 9. Because remember, if the last one's positive, they got to add to get that middle. So y'all, none of my factors work. So what did we put on this?
No solution.
Does not factor.
So it's a no solution. Now remember, in MATLAB, for no solutions, you got to use the 0 with a line to it. All righty, y'all. So I'm gonna let y'all write that down. That's it. That's all the 20 you got to know. Now, I'm not going to lie. If my number 20 is a no solution, 95% of y'all will probably get a no solution on number 20. I'm not going, well, probably even 99% of you. I'm not going to say 100% because MATLAB might throw me a curveball. But usually these tests, all they're doing is changing up a couple numbers. So if one's a no solution, then usually everything that is similar to that problem mimics those answers. All righty, y'all. So let me stop my share now. All right, so remember, this test is due Sunday night. And then what we'll do Monday, next week, we'll start the material for the last test. So we'll do probably about, let's see, we're on week 12 now. So we got what, 3 more weeks and then the finals. So we'll pretty much get the test 3 material out in the next 2 weeks. That way we can have a little time to study for test 4. And I want to do a review for the final exam also, okay? So we're on a good schedule now. So we got about 4 more sections. All right, y'all. So I'm going to quit the recording and then see if y'all got questions.